This video will demonstrate how to use the LoggerPro software to analyze a video that you have made or that you have acquired from somewhere. You'll have to look around on the computer desktop, look for LoggerPro. Pretty much any version will do, and it is installed on all of our lab computers and some other computers on campus. Open it. The LoggerPro opens up. Here you have an area that eventually will graph your data. Here you have an area that will eventually record the numbers for your data. And X and Y have meanings. They refer to horizontal and vertical. We'll see that in a minute when we have the video. To analyze a video, you first must have a video to analyze. Certain formats will work, certain will not. If you take a video off the internet, you may have to work with its format. I will show you a couple of ways of getting the video, assuming that the format works. Method 1, you insert a movie. You insert a movie when you have a video that you have taken and you have transferred it to the computer somehow. In this case, there are some built-in that came with the software. For instance, basketball shot. Here is the window that will then show you the video that you're bringing in. Helps to move the cursor down, make the window a little bigger. And you should always play the video and make sure everything went well. If you see a black screen, then probably you need to work with the format of the video, and your instructor will have to help you with that. Another way that you may use in lab is to make the video in the lab. In that case, you might hook up a video camera to the computer, or what I will do is use the camera built into my computer monitor. Again, you go to Insert, and now Video Capture. It will actually capture the video coming off of the camera. Click, and there I am. Your camera may pop up some controls. You probably don't need to worry about them unless the display has problems. So I will close that. So when you're ready to start the capture, that means you're ready to actually take the video you analyze. You will click on Start Capture. So you might want to practice a few times, make sure everything fits on the screen okay. Click Start Capture. And when you're done, click Stop Capture. You probably don't want a huge length of video. Stop capture. Okay. That one was a little longer than I wanted, but we can manage with 10 seconds. This will show you the size. Okay, you can now close the capture window, and the video window that we saw before will pop up behind it. So again, I'll make it a little larger so I can see what I'm doing. Click on play to make sure everything went okay. Click Stop Capture. You probably don't want a huge length of video. Alrighty. So you may not want to analyze the whole video. You can use these buttons down here that have the little double triangles to kind of step through the video. So it looks like I can start at the beginning, Um, and I'll probably want to stop about a third of the way through. That's when things stop being interesting. This button here with the left pointing triangle and a line to the left will take you back to the beginning quickly. Or you can go anywhere you want by dragging this little slider. Now to analyze the video. And by analyze video, what I mean is we're going to pick a point on the object, or you can pick multiple points if you want, and we're going to follow the motion of that point on the object. So I am going to pick the tip of my pinky. So to get the tools to do the analysis of the video, you see this button that has the 3 red dots and the right pointing triangle. You click on that and the tools all show up here. One tool that's useful is the tool that is the third one down that sets the origin. Strictly speaking, you don't need to set the origin yourself, but it's helpful to know where the origin is. So I will click on that. Light gray means it is not active. I click on it. Dark gray, it is active. I see a crosshairs. So I can move the crosshairs where I want the origin to be, where I want the point x equals 0, y equals 0 to be. I will pick the initial location of my pinky. And you see now we have a horizontal line, which will be the x coordinate, and the vertical line, which will be the line showing the y direction. Okay, so that is set. Down here, the second button from the bottom, you'll see that is dark gray. It says show origin. I'll turn that back on later, but for now, to declutter the picture a little, I will turn it off. Because when I'm analyzing the video, I don't need to worry about where the origin is. Now, to follow a point on the object, in this case the tip of my pinky, you use the second tool from the top here, add point. Click on it so it is dark gray, and again you see crosshairs. The way those will work is when you click at your chosen point on the object, it will locate that point for that frame and then automatically advance to the next frame, meaning automatically advancing time. So if I click, this is the first frame, and this blue dot is showing me where my pinky was in the first frame, and it is advanced to the second frame. And back here you can see on the graph, it is putting dots for the x and the y coordinates at this time, and it automatically picks time to be 0 for the first frame. So we just continue with that. Pick the pinky, the pinky, the pinky, tip of the pinky, and now my pinky's slowing down, so the dots are getting closer together. I must have sped up again. Now they're getting closer again. Now I got a point where things are going to start getting crowded, and the dots are making it hard for me to click accurately where the pinky is. These dots help you see where the motion is, but for analyzing, sometimes it helps to turn off this trail of dots because they just get in the way. So the third button from the bottom, which is dark gray, meaning it is active, says toggle trails. Trails refers to those dots. These dots that show me the position at the various frames. If I click on this, it is now light gray. It will no longer show the dots as I click. And that just reduces clutter, especially when the dots are getting close together. And when I'm going back where I was, if I turn the trail on for a second, you'll see it's really hard to tell which part of the motion is which. So I will keep going for a while. And let's do a couple more points. Let's get to one more turnaround. Okay, so looks like my hand's slowing down and turning around. Let's go a little past the turnaround. Okay, so I will leave this video analysis window there, but now I want to look at the data and the graph. So I can right click on the video and say move to back. Now it's out of the way. So what do we have here? On the left here we have the data table. Okay, I'm going to expand this out a little. And move the slide bar all over so I can see everything. It takes the time by using whatever timing is in the video. So the first frame is time 0. The second frame apparently is about 0.067 seconds, and then about 0.13 seconds, and so on. The fourth frame is at about 0.2 seconds. From this information, we can tell something about how fast the video was taken. If the video rate is faster, more frames per second, then these times will be closer together. If I look at this, I can see from the first frame to the second frame, or the second frame to third frame, if I subtract 0.06667 minus 0, then I can see the time between each frame. So it does one frame every 0.06667 seconds. And you can check the math that if I go 0.06667 seconds after the second frame, I get to the third frame. So this is the time per frame. If I take the inverse of this, if I take 1 divided by 0.06667 seconds, and I can do that, using the built-in calculator. So 1 divided by 0.06667 equals very close to 15. So this video taken by the camera in my monitor, this video was taken at 15 frames per second, and that is fairly common. Another video rate you will see quite often is twice that rate, 30 frames per second, which means you're taking the video faster and you can analyze the motion in a more detailed way. If you need even faster rates, we have cameras that can go up to roughly 1,000 frames a second. So they are measuring the motion every 1,000th of a second, every millisecond. These columns X and Y refer to horizontal X and vertical Y coordinates with the origin that we picked before. Now you'll see that the time here has the units of seconds, but it is not showing the units for X and Y. LoggerPro also can calculate the velocity in the horizontal direction and the vertical direction. And again, you'll notice the units are not there, which is a little disturbing. If you look at the graph, you'll see it puts both X, the red dots, and Y, the blue dots, on the same graph. We have the time down here in seconds on the horizontal axis. The vertical axis has numbers, but these numbers don't have units. And the number 100, what does that mean? Is that millimeters, centimeters, inches, furlongs, light years? The problem is the computer does not know. And the reason is that all the computer knows is pixels from the video camera. The video camera has a sensor that has little pixels, little elements. And all that LoggerPro knows is which little pixel did I click on. So we have to teach the computer what the scale is. In a sense, what do the pixels mean in terms of real distance? And I just clicked in a random place, so I'm going to turn the trails back on. Okay, I don't see a feature to get rid of the last one. So we'll just go back here, go to the data table, and we'll just erase that last point because that was spurious. I simply clicked in a random place. Okay, we may have to do that later. Okay, so if I want to stop clicking on points, I click on Add Point again. No, I don't need to do that. Okay, what I want to do is to set the scale. So what I need to do now is to give the computer some information so it knows what real distance is in this video. And the Set Scale tool is the fourth button from the top, Set Scale. Click on it. It is now active, dark gray. And basically I will drag the cursor along a length that I know. And that length needs to be in the same plane as the moving object. It needs to be the same distance from the camera as the moving object. In this case, I have measured the distance of my ring finger from the tip to the middle of the ring, so I drag across that. And it says, okay, so that length in the video is what physical distance? And I have measured that as 6.5 centimeters. And I click on OK. And you saw in the background something happened. So now I can send this movie back to the back. And you'll see that my data table now has the units. And my graph axes now have the units. We have this one spurious point here. But we'll just ignore that for now. To analyze, you'll see that, well, these look like some nice curves. If you remember some mathematics, this one is a little unsmooth here. This one looks like it might be some kind of sine or cosine curve. Not centered here, but maybe centered around here. Okay, so that's the y data. So if you want to say, okay, does a particular math function describe the data? You can go to this button up here that says Curve Fit. It is the second button from the right. You click on it. And in this case, I want to look at the y data, those blue dots. So choose that radio button. Click OK. And it gives you all of these functions you can try. Now that one to me looks sinusoidal, so I will try a sine equation. Then you can click on Try Fit and see how it looks. And it's not perfect, but it gives some of the general behavior. So when I closed that, a little box pops up here that shows me the equation, shows me the parameters in the equation, A, B, C, and D, shows me the numbers that the computer calculated using statistical methods that represent the best numbers for this function to fit the data, to describe the data, and also gives you the uncertainty of those numbers, which is fairly important. It's saying that, well, this is not a perfect fit, so we are uncertain about these parameters by this amount. You could try other functions. Maybe for the x data, I will try something more complicated. So let's do a fit. for X. And wow. Basically, you can fit anything you want to a big enough polynomial, but the more terms you have in the polynomial, the less meaning you have. So let's see what a cubic looks like. It's not a parabola, but maybe a cubic would do the trick. So try fit. It's a little bit off. Let's add one more. Let's add a fourth power term. Try it again. And it's a better fit, perhaps. Again, you can keep doing this and get better and better. If I go to a 5 polynomial fit, it looks like it's, well, hard to tell if it's better or not. I'll stick with 4. And click on OK, and again, it creates a box that shows you the numbers that go with their fit and their uncertainties. These fits do seem to meet what I refer to as the eyeball fit to some extent. The curves should roughly follow the trend of the data. With the blue dots, it's a little bit off. With the red dots, again, it's a little bit off, but the statistics will make it so that some of the dots are above the curve and some are below the curve. So you have to use a little discretion here. For instance, the third button from the right says linear fit. That applies a simpler statistical method that fits something to a straight line. So let's say I want to see if a straight line describes the X data. And you can just try it. It says, okay, here is a straight line fit to that data. The statistics say that is the best straight line for that data, but the eyeball says it's not even close. So please use a little discretion. The statistics don't always tell you the whole story. And finally, I can get rid of that spurious last point. Click on that line to select that row, and go up to Edit, and there's actually an option here, Strike Through Data Cells. So you can see those points are being marked here. If I strike through data cells, they're gone.